Welcome guys to this tutorial video. It's Automation Gizmo YouTube channel. Today we'll be looking at PLC to PLC communication using message instruction of Allen Bradley PLCs. So this is a way you can exchange data between two compact logics or control logics PLCs using message translation. In an earlier video, you can check my channel for videos on how to exchange data through produce and consume tags. Please share, like, and subscribe to this channel. So the first thing we're gonna do, we're gonna create some tags that we want to um, read or write. So we're going to create two tags. We'll call them um, plant data, and it's going to be a float, and task data size of 15, and I create real. Okay, and on PLC2 I'm going to create another data, call it my data. So one thing we want to know about exchanging data between two PLCs with message instruction, they both have the two data in the two PLCs have to be the same size of element and the same data type. Yes, so in this video I will be simulating my PLCs. I already have my RS links running and my Studio 5000 Logix emulate controllers running full. So I have two PLCs set up here on slot 2 and on slot 3. Okay, so I'll call this my data, and it's still going to be a real 15, and I'll create. So going back to PLC1, I'll go to the main routine and create a message instruction. So you navigate to input/output, and you see MSG, so message instruction. Drag this, and I'll give a name for the message control. I'll just call it test message, and new tag. It's going to be a message tag, and I just press OK. So we're doing this on the first PLC1, as we say, controller PLC1. So we're doing this on the first PLC, and then you click this configuration dialog box to configure it. Now, message type, there are so many types: block transfer read, block transfer write, CIP data table, CIP generic, PLC2, that's other types of PLC, PLC5, SACOS, and SLC type PLC. So, but we are using two Logix 5000, and then we're going to our communication is going to be CIP. So you can either do CIP data table read if you want to read data, or CIP data table write if you want to write data. Or if you choose CIP generic, you're gonna have to do a lot of service types and configurations that you have to start selecting. So, but for this tutorial video, we're just gonna do data table read. We're gonna be reading values from PLC2. Now, source element. What is the name of the tag we are reading from? So I'll navigate to PLC2, and the name of the tag is my data. So I put my data. Number of elements. How many elements are we reading? I have 15 float values here set up. So I'll put 15. Destination element. Where do I want to store this data in this current PLC? So I want to store it in plant data. Okay. So I want to store it in plant data. So the next thing we want to do is I'll go to communication path. Where is this path? Where is this PLC? So already before now I've brought up the two PLCs in the back plane. I think for you to do this, you just PLC one is on slot 2, which is from here. PS1 is slot 2 and PLC2 is slot 3. So I brought out PLC2 here. So how do I do this? I new module. Okay, I could just delete it and bring it up again. So new module. I'll search for, since I'm using an emulator, I'll search for emulate. If you have a physical PLC, you search for the physical PLC device. Yes, so I'm using an emulator, I'll search for emulate. The version is this, and I call it PLC 2. The slot is slot 3. Press OK, and it creates on the IO tree. So it's do the same thing for on PLC2. You do the same thing on PLC2. Bring up PLC1, which is in slot 2. So you do the same thing on PLC1. So you do the same thing on PLC2. Bring up PLC1 in the IO Ethernet configuration tree. So back to PLC1, and I'm going back to our message instruction here for the place of, oh, we're just gonna have to do this again. So CIP data table read, source element is my data, number of element is 15, and destination element is plant data. Now, under communication path, where is the other controller it wants to communicate with? So I go to browse, and it's communicating with PLC2. Yes. So I apply and I press OK. Now I'll download this. So another thing is message instruction works on the rising edge. So like on the clock beats. So I want to bring up a normally close here. Bring up a normally close and use the AN bits, then AN bits for this. Okay, it's test message dot the energized bits. So I'm gonna use this. So at every enable bit, it's going to reset it as when it's done, and it's going to be like a form of a pulse. So I'm going to download this again. Right. So now I'm going to head up to second PLC, and I'm just going to download. Okay, and time to run. Okay, and I'll go to PLC2. And now, since we are reading data from PLC1, PLC2 data in PLC1, I'm just gonna do some edits here, and let's see, 5.6, maybe 5.68, 4456.998. I'm just gonna monitor and edit. So heading back to PLC1 and controller tags, plant data. Yes, voila. So we can see that the data in PLC2, we're able to read it in PLC1. So you can also configure this message instruction to be able to write data. So we need for read. So you can also configure this to be CIP data table write, which is writing data from PLC1 to the second PLC. It works almost the same way. Thank you very much, guys, for watching this tutorial, and don't forget to subscribe.